Brute force attacks are very common, and there are many different ways of implementing a brute force attack. In this particular case here, I want to show you how a brute force attack against an authentication scheme can work. And what we're going to brute force is the login to our sample vulnerable website. Now, in the background, behind my browser window, you'll see I have Burp Suite open. We're going to use Burp Suite to capture the login request from this website, and then we're going to take that request and reissue it with all sorts of different possible passwords until we find one that actually works and we discover what that victim's password is. So here's how we're going to do this. I'm going to jump into the internet properties of my machine. You can get to this through your browser or directly on your host operating system. And it doesn't matter if you're not on Windows either. This is the same process. What we're going to do here is go and set our proxy. So into LAN settings, and I'm going to check the user proxy for LAN box. And the address I'm going to use is localhost 127.0.0.1. The port I'm going to use is 8080, and that's the port that Burp Suite listens on. Now, when I say OK to this, all of my local internet traffic is going to be routed through Burp. And what I'm then going to do is log in and allow Burp to capture that request. So let's say OK to that. OK again. I'm going to enter my email address. And what we're going to do here is assume that we're trying to brute force the password for this user. So right now we don't know what the password is. So I'm just going to enter 12345678. And the reason I'm doing that is that I just need to be able to submit a request. That's all I need right now. Let's now log in. Now we've got an alert here because Burp has served up its own self-signed certificate, which my browser doesn't trust. This was an HTTPS request, which Burp has intercepted. Now, of course, under normal circumstances, you don't ignore browser security warnings. But in this case, I know precisely what it is, and it's entirely necessary in order to let Burp intercept that request. Now, Burp has jumped to the forefront, and you'll see that up in that top row of tabs, the proxy tab has gone orange. Let's go and take a look at that. Now, here is the request that we just issued. So we can see the path that it's posted to, /account/login, and then right down the bottom we can see the request body. So there we can see my email address and the password I entered, the fake one, which is clearly not right. Now here's what I want to do. I'm going to go down and right click on this raw request, and then we will send to intruder. When we do that, we can see the intruder tab goes orange. So let's jump up now and see what's on there. When we go up here, we can see the target, which is a host name. The port is 443 because that request was made over HTTPS. If we go over to positions, we'll see that every piece of data on the page that is untrusted data, so things that you could normally modify as an attacker, have been highlighted in orange. I'm just going to clear all those out because there's only one piece of untrusted data here I'm actually interested in. And that one piece is the password. So I'm going to select it and then go over and add just that one back in. Right, so this is what we're going to try and brute force. We're going to get Burp to keep issuing this same request and then modifying just this highlighted value here, so just the password. And what it's going to do is keep trying new passwords. So what we need to do now is jump over into the Payloads tab and then load a payload list. Now it's defaulted to my temp folder, which is the last place I loaded a list from, and I have got a file in here called passwords.txt. Let's go down and open that file up. What we now see just to the right of that load button is the contents of that file. And that file is just simply a text file with a password on each line. And this is the set of passwords which we want to try and use to brute force the account. Now I've just put some of the most common passwords in here. There's only about 10 of them. And in order to demonstrate how this works, one of them is my actual password for the site. Now normally when you do this, you'd have a much larger password list. You might have hundreds or thousands of them. But evidently that would take a bit of time to run. So we're just going to start with this list here. Now that we have that ready, let's go up to Intruder and start Attack. Now one thing worth noting here is that this is the free version of Burp. There is a commercial version which has features such as no time throttling, so it'll run much faster, but this is just fine for demo purposes. So let's say OK. What we now see is an initial baseline request, so what happens when there's no value in the payload, and then subsequent requests that are replacing that password value in the request body with one from the password list. Now here's the significance of this. Have a look down that set of requests and you'll see one anomaly in terms of the response. So every response but one is an HTTP 200 with a body length of around about 6 kilobytes. But one of these, row number 4, the one with password with a 0 instead of an O, responded with an HTTP 302 and a very small body, just 783 bytes. This difference in response indicates that the web application has behaved differently for this one password than what it has to all the others. And the reason is simply that once you log on successfully to this web application, like with many web applications, you get redirected. So that's the HTTP 302 with the very small body, and you get redirected back to usually the home page. So that's a great example of brute forcing a password. And you can see how simple it can be. It's just a matter of using a tool which can automate the construction of HTTP requests. Now you can use this same sort of approach against basic authentication or against other protocols, such as FTP. And certainly there are other tools available as well. You'll often see material on ethical hacking referring to tools like Brutus or THC Hydra. Do be conscious though that some of these tools are somewhat old. Brutus in particular was last updated in the early 2000s. There are more efficient ways of doing these tests now. But certainly the concept is the same. Automate authentication attempts such that you can brute force the scheme. And very often it'll lead to a result like this where you easily discover the password. Clearly, automation is enormously useful. So let's go and take a look at a few other tools that can be really useful when you're engaged in ethical hacking.